Halo. Live, Pak.
Waalaikumsalam.
Ah,
Reni, saya Bu Reni.
sehat. Belum mulai lagi, Pak.
Belum 8-nya kita buka kedai dulu, Bu. Nanti
Ah,
jam
belum.
9 baru kedai jalan, Bu.
Oke, oke, oke. Ambo live dulu ya. Ambo masih di jalan, Biko
Oke.
bergabung.
Oke,
Oke.
Bu WR.
Assalamualaikum.
Salam.
Salam.
Ini dari ITP juga join pasnya.
Oh ya, alhamdulillah.
Itu Bu apa WR2 di ITP itu. Lektor Bu Sureni.
Oh
Di
iya, iya.
UGM juga tuh S2-nya pasnya.
Kalian ada nampak ada Pak Dokter Jaras nih.
Apa nanti ya kalau terlalu banyak pasnya di YouTube juga ada pasnya sudah saya upload linknya.
Sudah di-share Pak ya?
Ada.
Oke,
Yanti
Pak.
absen tolong pasnya yang minta ya suatu orang dan yang ikut.
Oke, siap,
Oke, pasnya saya tinggal.
Iya Pak. Perspektif. Kita tunggu dulu Prof Jarasnya bergabung ya. Jadi agak sabar sebentar dulu ya. Nanti kalau apa di YouTube juga boleh dilihat. Kita juga share di YouTube live streaming gitu.
Selamat pagi, good morning.
Selamat pagi. Selamat bergabung, Prof. Jaras. Welcome to UNP.
Ya.
Selamat pagi.
Oke, terima kasih. Pak Kris tak ada?
Ya, barusan Pak Kris mohon izin sebentar, Prof. Beliau sedang dalam masa 30 menit interview calon kandidat new lecturer.
Oh, oke.
Bagaimana, Prof? Kita mulai saja, Prof. Nanti sebentar lagi Dr. Krisnya gabung.
Oke, boleh? Kita boleh mulai?
Oke.
Boleh.
Baik, Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Pertama-tama kita mengucapkan puji syukur kehadirat Allah Subhanahu wa taala yang telah memberikan rahmat kepada kita sehingga pagi ini kita bisa berkumpul bersama untuk mendengarkan sharing pengetahuan, berbagi ilmu dari salah seorang guru kita. Ini Prof. Jaras, ini dari dari Malaysia, dan mudah-mudahan nanti apa yang beliau sampaikan itu bisa diserap dan sangat bermanfaat nanti bagi kita semua. Kemudian setelah bering salam kita hadiahkan kepada junjungan kita Nabi Muhammad SAW yang telah membawa umat manusia ke alam yang penuh dengan ilmu pengetahuan seperti yang kita rasakan sekarang. Baik, pertama sekali yang kita hormati ini Prof. Jaras Salfaras. Welcome, Prof. Selamat datang di Universitas Negeri Padang. Meskipun kita bertemu secara online, daring, karena situasi dan kondisi yang tidak memungkinkan, namun tidak mengurangi semangat kita untuk belajar gitu. Sebelum mulai, saya akan bacakan atau perlihatkan CV dari atau identitas dari Prof. Jaras. Sebentar, saya coba share screen dulu. Izin menyampaikannya, Prof. Ini beliau dari University Malaya, Associate Professor Dr. Jaras Alvarez. Ini beliau panjang sekali, punya CV-nya sangat banyak. Ini administrative duties ini banyak sekali, Deputy Director, Quality Manager, pakar jaminan quality program, Deputy Director, Chairman. Ini sampai sekarang masih banyak sekali yang dilakukan oleh beliau, tapi kayaknya tidak mungkin semua kita bacakan. Kita lihat dulu yang penting saja. Ini academic qualification itu beliau PhD-nya itu pada bidang power electronics itu di University Malaya UM. Kemudian masternya di bidang electronic and drivers, power electronic drivers itu di University of Nottingham di UK. Kemudian bachelornya ini di kejuruteraan Electronic University Multimedia Malaysia. Kemudian beliau juga ini banyak sekali ikut membershipnya Malaysian Representative IEC, kemudian juga Institute of Engineer Malaysia, Ini bisa kita lihat banyak IEEE member. Ini IEEE member, kemudian teachingnya area of expertise, power engineering itu power electronic, renewable energy, solar energy, PVT, energy and sustainable development. Teachingnya ini banyak sekali. Nah, sampai sekarang kita lihat. Kemudian beliau juga banyak menghasilkan karya ilmiah yang terindeks bereputasi, yang bagus sekali. Ini WOS. Kalau kita ini WOS ini dari 2001, 2021, 2020, 2019, 2018. Kemudian jurnal beliau juga banyak. Ini tidak kita sebutkan satu persatu, ini banyak sekali. Kemudian beliau juga menghasilkan buku pada tahun 2017, Fuzzy Logic Based Encoderless Speed Control of PMSM for Hub Motor Driver. Ini fuzzy control system. Artikelnya juga banyak. Kemudian ini project research, ini private funding juga ada dari 2019 sampai 2021. Ini national investigation on thermophysical properties of nano enhanced phase change material for concentrate photovoltaic thermal. Ini banyak dari gerakan penyelidik University Malaya juga, fundamental research grant skema juga OSCAM. Kemudian pernah juga jadi external supervision. Nah, ini banyak, ini post graduate student beliau banyak. Kemudian ini beliau juga sudah menghasilkan banyak patent ini mengenai system for cleaning of photovoltaic thermal panel, photovoltaic thermal panel, photovoltaic inverter, and method for controlling. Kemudian photovoltaic tracking system, juga single fase multi string 5 level grid connected photovoltaic inverter. Kemudian juga banyak mengenai social responsibility. Ya, akademik ini banyak sekali, ini bisa dilihat, silakan dilihat dari nanti di website-nya di UM Edu MY. Ini di UM Expert ini. Nah, banyak sekali, panjang sekali. Ya, tentu dengan qualified beliau seperti yang sampai sekarang pasti banyak yang dihasilkan gitu. Nah, saya harap nanti bagi teman-teman bisa menyerap apa yang disampaikan oleh beliau. Oke, untuk menghemat waktu kita persilahkan kepada Prof. Jaras untuk memberikan sharing ilmunya. Waktu dan tempat kita persilahkan. Silakan, Prof.
Oke, terima kasih Dr. Aznil. Boleh panggil Dr. Azni, Pak?
Belum, dokter. Astil aja, nggak apa-apa, Prof.
Aznil, oke, terima kasih Aznil. Pak, sebelum saya mula, boleh saya tahu audien kita ini pensyarah ke ataupun student?
Bergabung, Prof. Ada pensyarah, ada student gitu. Ada juga pensyarah rekan kita dari luar UNP juga ada.
Oke, boleh.
Mungkin pakai Melayu boleh atau mix dengan Inggris juga boleh.
Mix dengan English lah. Sebab saya punya presentation dalam bahasa English, tapi kalau nak tanya soalan boleh lah dalam bahasa Indonesia ke bahasa Melayu pun boleh.
Oke, siap, Prof.
Oke, Aznil, saya berapa lama diberi jangka masa?
Seluasnya.
So, lebih kurang 45 minit saya present.
Boleh.
Kita boleh ada 15-20 minit untuk question and answer. Boleh?
Oke.
Kalau terlalu lama pun nanti jadi boring.
Boleh, Prof.
Oke. Alright, sebelum saya mula, saya mengucapkan ribuan terima kasih kepada Universitas Negeri Padang kerana memberi peluang kepada saya untuk mempersembahkan ataupun memberi lecture kepada student dan staff di Indonesia. Saya juga mengucapkan terima kasih kepada kawan saya, Pak Krisma Dinata. Dulu kami berjuang bersama-sama untuk menghabiskan PhD di UM. So saya mengucapkan terima kasih kepada Pak Kris juga. Mari kita start kita punya presentation. Saya share screen. Boleh nampak, Pak?
Boleh.
Boleh ya?
Ya.
Okey. So saya akan cuba deliver lecture ni dalam bahasa Inggeris sebab saya punya slide semua dalam bahasa Inggeris. Kalau apa-apa ada pertanyaan, boleh unmute dan boleh tanyakan soalan. Okay. So tajuk presentasi saya pada pagi ini ialah Power Electronics for Renewable Energy. As we know that renewable energy is one of the key topic or hot topic that people are talking about in the world, especially in ASEAN region. We have plenty of resources in ASEAN. For example, solar energy. We don't really have very good wind energy at this region, but we have very good hydro. We have very big rivers, long rivers. So we have a very high potential in hydro. Of course, solar, I've mentioned. And also geothermal in Indonesia. I think Indonesia is the leading geothermal energy producing energy from in the world. So we have plenty of renewable energy resources. So how are we going to utilize this renewable energy? Let's go through. So this is some of the statistics that I have gathered, right? So of course we know that China is the largest energy consumer at the moment, and we expect in few years' time that India is also going to be one of the largest energy consumer. Why? Because of this population, okay, and population and their economic is also growing very fast. So we they predict that in maybe another 10 to 15 years, India will overtake China as the largest energy consumer. So when you talk about energy, where does this electricity or energy is coming from? So mainly at the moment it's coming from gas and coal, okay, and also oil. So very little percentage of energy is coming from renewables, okay. But things will be changing. You can see the blue and the green. If you look at the green, so it's going to, so if you look at the green, from 2011 onwards, the green will be, the green portion of renewables is going to be the main energy source. And if you can see coal are decreasing, and also gas. Okay, gas will be there for quite some time, but you can see decrease in coal, but increase in renewable, and also decrease in oil. So the shift is towards the renewable energy. So when you talk about
ketemu dengan kita kemarin dia marah-marah kita apa ketemu sama dia
Mohon maaf Pak Aswardi. Pak Aswardi, mohon mic-nya Pak.
Okay.
Silakan Prof.
So Where does this renewable energy, the energy is coming from? So mainly, if you look at ASEAN region, we are looking at ASEAN region, mainly it's coming from hydro because we have very big rivers and basically rivers. So mainly it's coming from hydro, and the wind little bit, and also the solar, and other renewables such as biomass and biogas. So this is again the statistics showing that there'll be an increase in renewable usage of renewables. So coal is almost going to be the similar, and actual natural gas is going to be remain the same. So you can see the increase in renewable share by the year 2040. So this is a global energy overview, and again the main energy is coming from hydropower, okay, followed by wind and also solar. So these are the three main contributor or source of energy at the moment, and the little bit on bioenergy such as biogas and biomass. So this one is not very popular at the moment, but you can see that the solar, wind, and hydropower is the most dominating renewable energy in the world. The big chunk goes to hydro power because when they build hydropower plants, it's all in very big size, gigawatt range. But you can't do that with wind and solar. So that is why the big chunk here is dominated by the hydro. So here again is a comparison between solar and wind. There is no doubt that wind, if you compare wind and solar, wind will be the dominating because many in European countries, they install wind power, and also the installation of wind power can be huge. Okay, one turbine can be about 5 to 10 megawatt range, whereas for solar, you can do that, but you need a lot of space. So in solar PV market, there is no doubt that the capacity is increasing from day to day or year to year. Okay, there is a huge potential of solar in this region because most of our region, ASEAN countries, Malaysia, Singapore, Thailand, and Indonesia, and also other countries, Vietnam, Cambodia, they are located close to equator. When we are located close to equator, we get a lot of plenty of sun. Okay, so this is one of the reasons that in this region the PV installation using.
Kalau Jo siapa? Kalau Jo orang rumah Pak Engki kan tak selesai.
Pak Reski, udah mau apa masa kolektor gila aja. Itu
Iyalah. Ya udah itu jurusan itu kan?
Iya. Ambo kan jual Bu Ian lo dulu tuh.
Iya.
Sampai kini ada jual dua lab kamu cepat kadang orang dapat dua mah.
Oke, Cian. Bien. Awak sekampung Bu ya?
Maaf Pak, suaranya bocor Pak.
Cerita ke Bu Ian, kamu lebih apa? Aduh Pak, aduh untuk apa? Aduh aja. Tapi aduh.
Maaf Pak, suaranya bocor Pak.
Acuan mau
Halo Pak.
Kok pengen aku mari aja.
kayaknya adminnya bisa kan secara paksa admin menutup. Adminnya mana mau ada yang menutup?
Kepayan tuh ya.
Pak Snil.
Hostnya.
Silakan aja Pak Snil.
Ada stempelnya beri.
Hostnya bisa kok
kan sudah dia kok.
Ada stempel
semuanya.
Sebentar.
Pokok ada stempel nah. Ada stempel lah.
Bagian kakak Bu ini kok.
Pak Lizar, mohon maaf Pak, mic-nya Pak.
Tengah di tangan di kepala.
Langsung guru besar deh. Langsung guru besar.
Guru besar kan sama lah, ibu lo orang.
Orang kebo kalau menasara ngalah kebo. Ini ada menasara orang kebo.
Oke.
Silakan lanjut Prof.
Boleh ya? Okay.
Ya, Pak.
So if you look at the solar PV market, You can see that China is dominating, and followed by United States, Japan, Germany, and the rest of the world. Okay. So now the trend is moving towards ASEAN, because there are many ASEAN, I would say ASEA, because many countries in Asia is taking up this solar energy project, especially India. They are going to build they're planning to build one of the largest solar plant in the world. Okay. All right. So coming back to our topic, which is power electronics. Okay. So when you talk about renewable energy, all these energies are being converted into electricity. So when you convert energy to electricity, you have to take care the quality of the energy or the quality of the electricity that is being produced. So this is one of the main reasons why power electronics converters plays a very important role. Okay, so when you convert energy it can be from hydro, can be wind, or can be solar. When you convert them into electricity, you either get it in the form of AC or DC. Okay, so but we have to understand that most of our application are all on the AC. All right, so we have to make sure that the DC that is being produced from the renewable energy can be converted into AC. And when you convert, the AC power should be clean and usable for the consumer. At no point you're converting DC to AC, but it is not usable. We have a lot of harmonics, a lot of the waveform is not very sinusoidal, so it can disrupt the equipment that is being used. So we have to make sure that the electricity that is being converted from DC to AC must be clean. So this is where the application of power electronics come into the picture. Okay. So here I put it here. Renewable energy sources, you can have it from wind, solar, biomass, bioenergy, any other form of renewable energy. So most of it will be on the DC power, and it is uncontrollable because it's coming from the nature, right? So you cannot control. So this is where the power electronics comes into picture, where we can regulate the DC or the AC power. Okay, so this regulation is purely done by the power electronics converters. So when you have regulated DC and AC, especially the AC power, then you can use it as a load, or you can transfer it to the grid. Okay? So now you can see what is the purpose of power electronics. Basically, it is to regulate the DC and AC power or convert one form to another form. So this is the main reason of power electronics. So in order for you to convert that, you need to have controllers. Okay, so you have to have power electronics equipment, and also the main important thing, or the brain of the system, will be the controller. Okay, so this controller will basically control the signals and also how these switches or the devices to be performed. Okay. So for example, you have fuel cell here. Okay, fuel cell, and you need the power electronics to convert it to AC. Okay, so the fuel cell, the output of fuel cell is DC, variable DC, so it varies. Okay, the voltage varies. So you need a power electronics converter here to convert it to AC source. So here in this case, we use an inverter, right? Because inverter is converting DC to AC, right? At the same time, you can have DC because the output from the fuel cell is DC. So you can have an output DC, but in this case, we should be a regulated DC. So you cannot connect direct straight to the fuel cell without the power electronics, because the output from these fuel cells are variable DC. So in order for you to get regulated DC or constant DC, so you need a inverter as well, or any other power electronics equipment, for example, DC-DC converters, in order to make it regulated. Then you also can use it to convert to AC, So for example, AC loads, we have laptops, TV, and other equipments. So you can also use this power electronics, basically the inverter, to convert the DC to AC. So basically, if you can see this picture, its main task is to convert DC to AC, okay, and also for regulated DC voltage. So, but in many cases, we don't really use regulated DC voltage. Okay, you can see the picture. We don't really use regulated DC, so mostly it's on AC, right? So here is some write-up on the power electronics. Basically, it's an application of solid-state electronics to control and conversion of power. As I mentioned, to control and convert the form of power. Okay, used to drive any device that requires an input of electrical power that other than the supplied primary power source. Okay, basically it's convert electric energy from one type to another type. Okay, so basically we use this in high efficiency lighting, motor controls, and wide range of industrial controls. Okay, so this is some of the example of power electronics application. If you look at your air cons, your refrigerator, washing machine, and other devices, they have come out with this technology where they incorporate inverter into your electrical devices or appliances. For example, the most popular one is the one air cons, okay, air conditioner, where you have an inverter technology there. Of course, the air cons with inverter technology are more expensive than the conventional, but they can save you some money. All right. So you have a refrigerator with automatic defrost and also a neuro inverter here. Okay. So the main purpose of these inverters are basically to save energy. Okay. Here for this washing machine, you have also inverter there, and they give you about 10 years warranty. Okay, this is some of the examples. Right, there are many examples where the application of inverters or application of power electronics is widely used. For example, if you go to the big factories, they use a lot of motors. So how do you control the motors? It's through power electronics. Okay, we call it power electronics and drive. So they use power electronics to drive the motor. Okay. So before I give you one good example of power electronics application that will be on the solar inverters. All right. So before we go into that solar inverters, if you look at this one, okay. So the output of the inverter varies with radiation. Okay. So when you have 1000 watt per meter square radiation, the output will be higher, and subsequently, if it is reducing, then your output power also reduces, right? So you can see a great what they call better usage of power electronics in solar inverters. So as I mentioned, the output from solar. Okay, you have a solar panel, you put it in the sun. The output of the solar panel will be DC. Okay. So with DC power, we can't do much because the usage of DC power is very less in our daily life. We don't really use DC. There is no countries in the world that uses DC as their main power source. So all of them uses AC. So in order for us to convert the DC to AC, which can be used for not only by us, but by others as well, we need to have inverters. So these inverters basically converts the DC to AC, which is usable for human being. All right. So there are 4 types of inverters that is commonly used in the solar system. Basically, the central inverters, the string, module integrated, and multi-string. I will go briefly on this because some of you have learned this, or some of you can Google through this, and there are a lot of information available. Okay, just hang on, just 1 minute. Okay. Sorry for the interruption. So for central inverters, the main criteria for central inverters will be you need to have high voltage DC cables, power losses due to common MPPT, power loss due to module mismatch, and there is a lot of losses. Why? If you look at the central inverters, this is one of the example of central inverters. You can see this in some of the solar plants. Okay, they are huge. Okay, so they are huge. So when you have huge inverters like this, so definitely they will be going to be a lot of losses. Okay, this is one type of inverter that is available for solar system. We call it as central inverters, and they are one system. Okay, you can only see one. We probably if you're a big power plant, then you can see many of these. Many means not 100, 200, probably 3, 4, 5, something like that. Okay, they are huge. Okay, so you need to have expertise to install, and also maintenance wise you have to take care. All right, so they are huge. Okay, this is another example. Okay, this is how they've been set up. Some of them are located inside a room. Okay, and nowadays I see most of the central inverters are located outdoor. Okay, in previous years, when we go for testing and commissioning, most of the inverters will be located inside the room, and the room must be ventilated properly because there's a lot of power electronic switches. Okay, and there is be a lot of sorry. There's a lot of heat being generated, so so we need to have a proper ventilation. String inverters, these are the inverters that are being very famous at the moment. Okay, they are very little losses, they have separate MPPTs, and they produce better output. Okay, so better yield. Okay, I think most of you have seen this. You can see this you can see this in many power plants, and they are not big. Okay, they are not small either, so they are in a medium range size, and nowadays the capacity can go up to 100 kilowatt. Okay, so these are the string inverters. All right, you can see, and they can be placed outdoor. Okay, so no point nothing to worry about on the rain, on the sun, so they can be placed outdoor. Okay, so when it is module integrated inverters, this is very new technology. I wouldn't say new technology, it's been there many, but not many people are using. So this is where the inverters are placed at the module. Okay, so each module will have one inverter. Okay, so they have advantages and disadvantages. So let's look at the advantages. They have a rapid shutdown capability. They can shut down very fast. They can produce more electricity, less losses because it is connected very close to the inverter. Okay, and you can monitor them at the panel level, right? And you can expand them. That means you can add on panels when you have money or you have space. You can just add on. Okay, you don't have to worry about the space adding on. And whereas for string inverters or central inverters, especially the string inverters, you need to worry on how many panels that they can be connected. When you reach the maximum capacity, then you cannot expand. But with this micro inverter, it can be expanded easily. For the disadvantages, the cost, maintenance, the cost is very high, and of course the maintenance is high, and it adds more weight to the roof. Okay, basically this kind of system, it is installed at the rooftop. Okay, so when you add more weight on the panel, it's going to increase the weight of the whole system. So it's more hardware and more weight on the system. Okay, so this is the configuration of a multi-string inverter. Multi-string inverter is also the same as a string inverters, but the only difference is you have many strings connected to one inverter. All right, so this is an example of multi-string configuration. Okay, in this case you have many levels here, so I don't want to go the detail on the levels, but I just want to show you the strings. So you have string number 1 here, string number 2, and string number 3. These all strings are connected, okay, and then they are connected to a inverter. Okay, of course you have a DC-DC controller here and also an inverter here. Okay. Okay, this is another example of usage of power electronics. So power electronics can be used as a driver, right, for motors. Okay, so when you want to control the motors, either you can control through the frequency or through the amount of voltage that will be supplied. Okay, so these two things can be done by using power electronics equipments. Okay. So inverter technology topology, normally this is a typical inverter topology where you have a DC-DC converter here. Okay, the main reason for you to have a DC-DC converter is to track the MPPT, all right? And once you track the MPPT, MPPT is maximum power point tracking, where it extract maximum power from the solar. So if you don't have an MPPT tracker, the PV modules might not be giving you the maximum power. It might give you maybe probably 70%, 80%, or 60% of the maximum power. Basically, this MPPT or DC-DC converter is to extract the maximum power from the panel. So if it goes to the inverter, so inverter will convert into AC, and it goes to the filter, and it goes either to the grid or to your load. Okay, so this is an example of a DC-DC converter. All right, so we have a boost converter here. So basically, it is an MPPT tracker, maximum tracking. Right, so it goes into a single phase inverter. All right, so when this is a DC, the output is an AC load. So this is again, this is a 3-phase. The previous one is a single phase inverter. This one is a 3-phase inverter. All right. So utility compatibility. All right. So why we need power electronics? Why we need to convert, and how efficient it should be? So most of our renewable energies are connected to the grid. Okay. Example, like in Malaysia, 80%, or say 80-90% of the solar system is connected to the grid. So when you're selling power to the grid, first thing you must make sure that you are compatible. Okay, the grid has its own standard. Okay, in Malaysia we have we call it as Tenaga Nasional Berhad, TNB. So this Tenaga Nasional Berhad, they are the one who's taking care of the electricity, the network, the transmission, the distribution, and everything. So if you are an independent distributed generator, okay, we call it DGs. That means you are producing your own electricity and you're selling it to the grid. You must make sure that the power that you produce is compatible with the standard. Like Tenaga Nasional Berhad, they have your own standard. Okay, they have to make sure the frequency is right. You must make sure the voltage is right. You must make sure that there is no harmonics or very little harmonics. Or you must make sure there's no flickers. There is no DC current injection. You comply with the safety and regulations. So these are the main aspect of utility compatibility. Okay. So this is where the grid connected system, for example, PV system, has to comply with the grid system. So every country have the grid system, right? Our grid code. So like in Malaysia, we also have a grid code, very strict grid code. I'm very sure there is in Indonesia also there is a very strict grid code. So you have to comply with the grid code. If you don't comply, then you are basically polluting the grid. Okay. One good example is how you are polluting the water. It is the same. Okay, the same concept for electricity as well. So you don't have clean power, you don't inject to the grid. Okay, so make sure the power that you are injecting to the grid is clean. Okay, so how to clean this? How to make sure the power that you are injecting is clean, or you want to clean the power? So this is where the power electronics equipment or power electronics application comes into the picture. Okay, before that, we look at the grid connected PV system. So you have PV system here, we have inverter here, and then we have a grid here, and in between you have switches for safety and also for disconnection. Okay. So if you talk about electricity, I think most of you are from electricity background. So three most important things on electricity. Without these three things, you cannot be an electrical engineer. First is the voltage, the second is the current, and the third one is frequency. Most of all of our application involves these three: voltage, frequency, and current. This is how you control. If you manage to control this voltage, current, and frequency, then you're an expert in this field. Okay, so basically it's voltage, current, frequency. Other than that, I don't see any other big terms in electrical engineering. So basically this is how you do it. All right, so for voltage level we have regulation, so to make sure that the variation is within the standard. For 400 volt and 230 is plus 10% minus 6%. So we have to make sure that the voltage doesn't goes beyond 400. You can go beyond 400, but you should be within plus 10%. Okay, and also when it dips, you should not go below 6%. So for medium voltage, 3311 kV and 33 kV, so it's plus minus 5%, and for high voltage, it's also plus minus 5%. So when you measure, it always must be within this range. And also the frequency. The frequency in Malaysia is 50 hertz. I think in Indonesia it's also 50 hertz. So we have to make sure the frequency also does not exceed the 50 hertz range. Okay. So again, this is for single phase and three phase, right? So utility connected PV system do not normally regulate voltage. They inject current into the utility. So normally we don't regulate the voltage, because when it is connected to the grid, we are seeing the grid. Okay. So what we do is we regulate the current. Okay, we cannot regulate the voltage because since it's connected to the grid is the responsibility of the grid operator to regulate the voltage. What we can do is to regulate the current that is being injected to the grid. Okay. So therefore, the voltage operation range for PV inverters is selected as a protection function that responds to the abnormal utility, not as a voltage regulation function. So what we do here, what it's saying that we don't really regulate the voltage, only we are looking into the current. Okay. Another important criteria is flickers. Okay. So we have to make sure the flickers is within this range. So we normally measure two types of flickers, which is short-term flickers, 10 minutes, and long-time flickers, which is 2 hours. So it should be within this range. And DC current injection. Okay, let's talk about DC current injection. When you convert, what is actually DC current injection? DC current injection, basically, it's when you convert DC power to AC power, there will be definitely DC component exists in the AC. Because you're converting from DC to AC, there will be a little bit of DC influence or DC power exists in the AC. Okay, normally we call it as DC current. All right. So this DC current, we are not saying that you cannot have cannot have at all. Yes, you can have DC current injection, but it should be 1% of the rated output current. Okay, let's say you are measuring 1000 amps. So 1%, you should be getting about 10 amps. So your DC current should be lesser than 10 amps. So how to measure this? This is quite simple. You have to have a very good clamp. The clamp, the current clamp. Okay, when you clamp it, you should be able to measure both the AC and DC. So your clamp meter must be capable of measuring AC and DC. So what do? You measure the AC. Let's say you're measuring about 1000 amp AC. So you change back to DC and then you measure the DC. All right. So you take the percentage. Let's say your DC current is 9 amp. Okay. So 9 amp. So 9 amps divided by 1000 should be 0.09%, right? Less than 1%. Okay. This is how you measure the DC current. Okay. So harmonics. Okay. Harmonics is also very, very important because this is one of the major problem for grid operators. Okay. When people injecting power to the grid, harmonics is the one is causing a lot of problem for them. Okay. When we talk about harmonics in this case, we normally talk about current harmonics. Okay. I'm very sure some of you know the term current harmonics, total harmonic distortion. Basically, current harmonics is a measure of the departure of AC current waveform from the sinusoidal shape. See? So how it is different from the sinusoidal. If you have a very pure sinusoidal, then we say it is less harmonic. It has less harmonic content. But if your sine wave is not pure, you have distortion here and there, then we can say that there is a lot of harmonic present in this sinusoidal. Okay, by looking at the sinusoidal waveform, we can tell them whether the harmonics content is high or low. Okay, so that is current harmonics. Total current harmonics. Before that, current harmonics comes in many forms or many subsection. We call it as odd harmonics, even harmonics. So when you talk about hot harmonics, it is in the form of third harmonic, fifth harmonics, all odd numbers. Third, fifth, seventh, ninth, 11th, and so on. Okay, when you talk about even, it is 2, 4, 6, and so on. So total harmonics is a combination of all these odd and even harmonics. Okay, because I don't want to lecture you on the harmonics because it's a very big topic, and also maybe if you don't really understand, you can go back and see what is harmonics. Basically, it's they break it, the sinusoidal wave or the fundamental into or not the fundamental, the sinusoidal that you have into fundamental, into the first, second harmonic, third harmonics, and the combination will be your sinusoidal wave. Okay, voltage harmonics is the same. So we have limitation for odd and even harmonics. So if you look at the third until the 9th should be less than 4%. 11 to 15 should be less than 2%, and etc. etc. Okay, you can go to the power factor. Power factor is one of the very important parameters that we measure. Okay, in electronics especially, because when you talk about sinusoidal or sine wave or AC voltage, basically you're talking about three different types of measurement, which is voltage measurement, current measurement, and the frequency measurement. As I mentioned, this is three important parameters. So when you have voltage and current, you always can measure the power factor. Okay, power factor is how different is your sinusoidal and sinusoidal voltage and sinusoidal current in terms of phase difference. Okay, so can break it into three: active power, reactive power, and apparent power. Right. So this is one example. So the power factor is being calculated. So when you have active power and then you have reactive power, then you always can calculate the apparent power and also the power factor. Okay. So this is one example. I don't want to go detail on this example because it's time consuming. if you want, I can forward the notes to later on to your Pak Chris or Aznil, so you all can get the notes from me. Okay, so this is how you control. You install in previous this one. The factory doesn't have a PV system, but next they're planning to install a PV system on that. So when they install a PV system, the power factor gets bad. Okay, if you calculate this power factor is 0.77, but the inverter is you can program the inverter to inject reactive power, okay, so that your power factor is back to 0.95 or whatever power factor you want. So nowadays, the most modern inverters, PV inverters, they are capable of injecting or absorbing a reactive power. All right. Okay. So this is an sample of or notes on power factor. Okay. So all this power factor, flickers, harmonics, all can be done very easily. Okay. Now we have equipment to do that. So we call it as power quality and energy analyzer. Okay. You can get many brands. Okay. One of the very famous, reliable is the Fluke power quality and energy analyzer. So in this power quality, we can do many things. Okay, the only thing that you have to do is set the parameter that you want to measure. Okay, so it can measure the power factor, can measure the flickers and the voltage, the current, the harmonics. All right, the DC current injection. So it can do many functions here. So if you have a chance to get one of these, try to get one and try to explore on this power quality analyzer. Okay.
Makasih banyak Abang.
I think we have another 5-10 minutes. Maybe we can go through the power quality problem. So if you don't have a very good power electronics converters, so you can generate power quality problem in your renewable energy sources. Okay. So the power factor normally.
Pak, apa Pak?
Okay, so when the power quality, when we have a power quality issue, as I mentioned, when you don't have very good power electronics converters, you can create power quality problem, okay, into the system. So when you talk about power quality, it's always about voltage, current, and the frequency. Okay, so it can be a large voltage drop, okay, and power characteristic aligned with sinusoidal voltage and current. Okay, so it's always aligned with the sinusoidal voltage and current. So some of the example of power quality problem will be the voltage dip and transient, harmonics, flickers, and phase imbalance. Okay, so you can go through these notes on power quality. So basically, the power quality the term is used to describe the extent of variation of voltage, current, and frequency on the power system. Okay, very basic definition. Okay, extent of variation, how much it varies from the system. Okay. Some of the example of power quality problem will be voltage sagging, interruption, voltage swelling, transient. Okay, all these are some of the examples. So you can see how it is varying. Okay, this is swelling. Okay, this is sagging. Okay, sagging means the you can see here the voltage decreases, or the sine wave decreases in size. Okay, so that means the amplitude is decreasing. When you have swelling means suddenly the amplitude increases. Okay, so example here you can go through. So the major problem with power quality problem will be sagging, okay, and swelling. Okay, these are the two major problems that the grid operators facing when you talk about power quality problem. Okay, So how do they affect you? How this power quality problem can affect you? You can experience motors stall. Motors are not suddenly they stop because of this problem. Computer crashes because you have variation. Okay, that's why many of the big computers they have UPS. Okay, so when they use UPS, they have a very constant power supply. Okay, production, especially in electronics or manufacturing, is affected. Equipment damage, it can also damage the equipment because your voltage suddenly goes up and suddenly comes down, so it spoils the controller there. Okay, so that is why in Malaysia we have this procedure for the testing and commissioning of grid connected photovoltaic system in Malaysia. So this is where the inverters, all the PV inverters, need to be certified and need to get approval, okay, from Sustainable Energy Development Authority. So in this test, on this site test, we do power factor test, harmonics test, voltage fluctuation test, flicker test, DC current injection, anti-islanding, and steady state voltage measurement at medium voltage. So look, if you look at this, it's all related to power electronics. Okay, power factor is also electric. It's related to power electronic. All these are controlled by the power electronics equipment in the inverter. Okay, so why I'm mentioning this is because you cannot be seeing power factor, harmonics, voltage, flickers, DC current injection without the power electronics equipment. So all these power electronics equipment is the one who's going to control all this stuff. Okay, so you can go through the notes or the document. So it says the power factor must be more than 0.85 or 0.9, right? Harmonic should be less than the table in the given table, and the voltage fluctuation should be within plus minus 6%. And then you have flicker test as well. Current DC current injection, as I mentioned, is always less than 1% of the rated power rated current. You have anti-islanding as well, and also you have a steady state measurement for the medium voltage, which is mostly is 11 kV or 33 kV. So when you talk about medium voltage in Malaysia, it's always 11 kV or 33 kV. Okay, common tests for indoor testing. Okay, these are the tests for indoor testing, which I don't want to go through. This is some of the example of power quality problem. So when this is where the motor sudden or the production, this is from a biogas plant. When suddenly there is a drop in the supply in the biogas plant, and the turbine or the production of electricity goes down, and then it's goes back to normal. But this drop of that means the steam turbine is not getting enough supply, then it goes down and it ramps up back to the normal. So when this thing happens, you can see the medium voltage, the 11 kV system, it goes beyond the limit, which is plus minus 5%. And also there is an increase in the flicker, okay, more than 1%. Okay, so biogas plant capacity reduced from 1.7 megawatt to 1.3 megawatt. Okay, so when it reduces, this is where the flickers occurs. Okay, it is more than 1%. So there are many examples. So for example, this is an example from the PV system. So we have THD less than 5%. So in Malaysian system, the THD should be less than 5%. So you have THD less than 5%, and sometimes you have THD. This is a different group of inverters. Okay, this is a first group. This is a second group. The second group of inverters are giving very high THD value. Okay, why? Because they did not design their inverter properly. So when they don't design their inverter properly, this is what happens. Okay, THD is higher. Okay, more than 5%. Okay, so this is a problem. This is causing problem to other people as well. Okay, in this case, they are causing problem to the neighboring factory. Okay, this is a big factory. I mean, this is this plant is located at the industrial area, and they are causing problem to the neighboring factory. All right. So this is again some of the example. You have flickers before commissioning of the plant is very nice, but after commissioning of the plant is very bad. The one in red is it's not healthy or beyond the range that is given here, beyond the standard. Okay, so in this case we will inform that owner, or normally the owner, to look back into their inverter configuration, or also contact the inverter manufacturer or distributor to correct them. Okay, so this is some of the example as well, and this one is also on flickers. So many of our problem comes from flickers or harmonics. Okay, power factor we don't really have any problem because the inverters are very designed in such a way that to meet the expectation. But we always have problem with flickers and also the flickers and harmonics. Okay, these are the two phenomena that we always monitor. This is also on harmonics. Okay, you can see before commissioning, after commissioning. All right. So you can see here, this is a pattern of flickers. This is pattern of harmonics. So if you look at the red box, so your flickers goes. This is a 1-day pattern. So normally your flickers goes up during when the harmonics, the reading of harmonics goes up when the inverters are on. Okay, and it goes back when the inverters goes back to normal reading when the inverters are off. Okay, so you can see here it decreases during after 6 p.m. but increases in the morning about 7 o'clock, 8 o'clock. It starts increasing and it goes beyond 5%. Okay, and remains at 5%. Because the inverters, the PV inverters are on, they're supplying power to the grid. And when it is 6 o'clock, 7 o'clock, the inverter starts to shutting down, and the THD reading is going back below 5%. Okay, so this is an example. So we have a Malaysian standard. We call it installation of grid connected PV system. This is where you should be complying all the installation standard that is being provided. I'm very sure every country have their own standard. Okay, so you must make sure that you comply with this one. Okay, so this one I don't want to go further because I think the time is already this one. So this one you can read through the possible planning and solution for maintaining grid stability. You can go through the notes that is provided. All right, thank you very much. If you have any question, then we can have a question and answer session. Asnia?
Oke, terima kasih Prof. Itu tadi sharing session the knowledge atau pengetahuan yang diberikan oleh Prof. Jaras. Sekarang kita lanjut ke sesi tanya jawab, diskusi. Silakan Bapak Ibu atau rekan-rekan mahasiswa. Kalau silakan mau bertanya langsung boleh, kalau tidak, kalau rekan-rekan mahasiswa kalau malu bertanya langsung secara langsung boleh kirim di chat atau langsung kirim ke kita, boleh, silakan. Silakan Bapak Ibu.
Pak War, silakan Pak War. Pak Aswardi.
Pak Aswardi sudah bergabung. Silakan Pak. Halo, Pak Aswardi.
Oke, saya aja tanya nih, Dr. Jaras. Dr. Jaras. Sorry, baru selesai ini. Dr. Jaras, boleh macam mana renewable energy boleh stopkan protect flicker kat Malaysia?
kalau kita tengok sebenarnya flicker ni tidak menyelesaikan masalah. Flicker ni, renewable energy ni banyak menghasilkan flicker.
Oh, banyak pula menghasilkan flicker.
Banyak menghasilkan flicker. So tapi dekat Malaysia ataupun di mana-mana pun, kecuali di Germany lah, di Germany, peratusan renewable energy connected to the grid is very small. Malaysia is about berapa? Malaysia baru 20%. You jangan kira hydro. Kalau tak kira hydro baru 5 ke 6%.
Oh, okay.
So kalau you baca dekat literature, banyak engineers ataupun researchers dia memberitahu bahawa bila you punya installation capacity increase to more than 20%, baru you boleh tengok power quality problem dalam grid. So selagi kita tak sampai,
what effect the voltaic flicker to the dalam to stability power system?
What is causing the voltage flicker?
Yeah.
Okay. What the main reason for voltage flicker will be the switching of the devices.
Right. Okay.
Kan? So kita ada banyak switching devices dalam power electronics kan. So when you convert DC to AC, there is a lot of switching. So when the switching happens, when you don't really control the switching punya frequency, so this is where the voltage flicker happens. Kebanyakannya disebabkan oleh switching frequency dan switching mechanism. So you don't have really good PWM waveform, so you can it can create a flicker there.
Apa efek ke sistem kita? Itu kenapa boleh merugikan atau menguntungkan tak voltage flicker itu?
Flicker itu sebenarnya tak ada efek banyak kepada sistem. As I said, kan macam saya tadi kata tadi, flicker ni kalau dekat Malaysia ataupun dekat mana-mana pun sekarang dia punya renewable energy penetration is very small. So the effect of flicker is not reflected back to the grid. So it's a very small problem, still very small problem. But if you have more plant, more solar energy connected to the grid, then the flicker problem can become a big problem. It's a big problem. So at the moment there is no solution for flicker. Flicker ni kadang-kadang flicker ni dia bukan constantly happen. Dia kadang-kadang saja happen. So it's all depends on the grid and also the power electronics that you're using, the inverters that you're using.
Flicker ni boleh efek to merusak equipment tak? Kalau dia besar flicker ni? Terlalu tinggi boleh merosakkan equipment. Kalau terlalu tinggi. But at the moment, kalau dia, let's say, dekat Malaysia, it should be less than 1%. Yeah. Okay, less than 1%. So, apa yang kita monitor yang paling banyak pun 1.1%, 1.2%. Tak ada banyak macam 15%, 16%. Tak. Dia tak akan berlaku lah. The inverter is not that taklah teruk sangat macam boleh menghasilkan 15%, 20%. Tapi, 1%, 2% I think is not a big problem. Okay, Dr. Jas tu ada yang tanya tu. Silakan Pak Asniel atau bacakan Pak Asniel. Ada yang di chat.
Oke, terima kasih Pak. Ini di chat. Oh ini Bapak tadi Pak.
Ya itu yang ada student siapa tanya tuh. Sumber energi terbarukan.
Horis Otowiro, sumber energi terbarukan. Renewable. Ini bukan pertanyaan. Kayaknya ini bukan sebuah pertanyaan. Oke, Prof. Jelas. Dalam chat tu dia cakap bebas harmonik. Memang kita tak boleh ada sumber elektrik tanpa harmonik. Ada harmonik, mesti ada harmonik. Yeah. Tapi percentage dia kurang. Kita tak boleh cakap bebas harmonik. Mesti ada harmonik tapi boleh dikurangkan. Sedikit ataupun kecil. Less than 5%. Ya, sedikit kecil. Oke, Prof. Ini Saya sudah terima beberapa pertanyaan. Saya coba merangkum dari yang saya terima. Sebentar saya coba share screen. Ini kita coba rangkum tadi, Prof. Ini pertanyaan yang pertama. Ini future challenge power electronic in renewable energy. Yang berikutnya ini standalone PV, which one more effective, menggunakan sistem tracking yang mekanik tracking lebih sederhana atau menggunakan metode kontrol MPPT algorithm lebih complicated, more complicated. Terus yang berikutnya, ini kita tahu energi matahari dengan energi angin ini tidak konstan. Akibat posisi matahari dari pagi sampai sore, siang atau malam. Sedangkan konsumsi energi secara real time kita butuhkan. Kelebihan dari energi kita simpan lewat baterai.
Beko nanti kita tanggal 7 balik kita buka balik.
Tapi dalam beberapa jangka, dalam beberapa masa, baterainya tidak bisa dipakai lagi dan juga mengandung bahan-bahan yang beracun. Kira-kira adakah solusi yang bisa menyimpan energi untuk jangka waktu yang lama? Kemudian yang keempat, bagaimana cara memperbaiki harmonik? Kita tahu PV to grid salah satu komponen esensial adalah inverter. Nah, pada saat menggabungkan ke grid itu mungkin terjadi wave distortion. Nah, bagaimana konsepnya untuk memperbaiki harmonik yang terjadi ini? Silakan, Prof.
Oke. So yang nombor 1 itu kalau saya tak salah faham, standalone mana yang efektif menggunakan sistem tracking. Okey.
Iya.
Atau mechanism control MPPT algorithm. Okey, dia tanya saya kalau tak salah, if I'm not mistaken, dia tanya yang mana bagus, tracking ataupun yang static, kan?
Tracking mekaniknya yang bergerak atau metode seperti percept and observation, incremental, and others.
Okay. Okay. So of course, the answer is very simple. Bergerak itu akan menghasilkan lebih banyak electricity. Okay. Tapi kita ada banyak disadvantage. Okay, disadvantage-nya of course first is cost. Cost dia lebih mahal. Second, maintenance. Okay, maintenance. Tetapi kebanyakan sistem di mana-mana negara dia banyak menggunakan static. Okay, kenapa? Dia punya cost, as I mentioned, dia punya disadvantage cost. Siapa nak maintain dia? Okay, and then kebanyakan sistem ni adalah besar. So when you have a very big system, you need to have a very big tracking system, which is very costly. We have one plant in Malaysia which they use a tracking system. So according to them, when we talk to them, dia memberitahu dia dapat in terms of percentage, dia dapat 30% lebih daripada tenaga yang daripada static, lebih tenaga daripada yang static. So dia pakai yang tracking. So bila dia calculate 30% tu, dia kata dia punya lepas tolak dia punya maintenance cost semua, so dia tinggal 20% saja. So 15%. So dia cakap it's not very cost effective. Okay, cost effective having tracking system. Of course, itu 30% lebih. Tapi you have to spend a lot of money on maintenance and also the initial cost. So this is, I think this have answered the question. Okay. Tapi kebanyakan sistem dalam dunia ini tak ada yang banyak yang pakai tracking system. Small 1 or 2 panels, you want to do tracking system, 3 dimensional tracking, boleh, tak ada masalah.
Tapi untuk big system, very expensive, very complicated tracking system. Okay. The second question is energy.
Solusi untuk menyimpan energi dalam jangka waktu yang lama.
Okay, energy storage. Okay. At the moment, energy storage kita yang biasa ramai yang pakai ialah bateri. Okay. Dekat ada beberapa tempat, tak banyak, bukan 5 ke 6 tempat yang menggunakan in terms of dia akan pump air ke bahagian yang tinggi. Okay, bila dia ada excess energy, dia akan buat satu macam kolam di bahagian di kawasan belakang. Di store air dekat di atas gunung itu. Okay, dia buat macam satu kolam, dia akan store air di sana. Bila malam ataupun matahari tiada ataupun wind power tak ada, dia akan release the water. So when they release the water, dia akan pusing turbine, bukan macam hydro. Okay, but that is very expensive. Ramai yang tak buat sebab very expensive. Okay, at the moment the only battery storage that everybody is using is energy storage that everybody is using is battery. Okay, unless ada beberapa teknologi baru yang akan datang, kita tak ada. Tapi ramai yang menggunakan bateri dan mereka sedang menghasilkan bateri yang boleh menyimpan lebih banyak tenaga. Okay, so kita tak boleh lari daripada bateri. Okay, so battery is the only solution at the moment. Okay, bagaimana cara memperbaiki harmonik pada saat menggabungkan PV dengan grid? Okay, baiki harmonik very simple. Your power electronics controller have to be very efficient, and you can use filters. Okay, you design a very good filter, because if you look at the configuration, you have inverter before in between inverter and the grid. Okay, you have filters. You have to have very good filters. So you design filters properly in order for you to eliminate all these harmonics. Okay, and we have in power electronics we have active and passive power filters. Okay, so this as active and passive power filters, the main function is to filter the harmonics. Okay, so you can use a very good filters because filters is a part of the inverter technology or inverter development. Okay, you really don't have filters at outside of the inverter, but you combine the filters and the inverters together in order for you to produce the power. Betul Pak Chris,
Betul.
Number one, Prof, future challenge power electronic in renewable energy.
Future challenges power electronics in renewable energy. Yeah, a lot of challenges, because as I said, many are predicting when you reach more than 20% of the energy capacity that is being produced by renewable energy, then you will be having a lot of grid problems. Okay, so when you have grid problems, for example, grid shortage, grid tripping, this is all coming from renewable energy. So we have to make sure that the power that is clean and it meets the requirement of the grid code. Right? So yeah, there is a lot of challenges in terms of power electronics, where you have to design it in very in such a way that it meets all the regulation. I'm very sure the regulation is going tighter and tighter, getting as many people are injecting power to the grid, they want to tighten the grid code and also the regulation. So when it gets tighter and tighter, your power electronics also have to be has to function to meet the requirement. Okay, so I say yes, there is a lot of challenges in terms of meeting the grid code.
Oke, terima kasih Prof. Jeras. Bagaimana Bapak Ibu yang lain? Silakan pertanyaan selanjutnya kalau ada. Pak Aswardi, mana Pak Aswardi tadi?
Sekarang buat riset apa, Dr. Jeras?
Grace?
Buat riset apa sekarang?
Kami macam biasalah power electronics ada. Banyak sekarang power electronics kepada PV system dah berkurang sikit. Kami concentrate on charging EV electric car.
Oh, electrical charging
Sebab
macam mana dapat baterai? Baterai beli kat China atau Malaysia produce baterai?
Malaysia kita beli saja. Malaysia belum lagi produce battery.
So sekarang riset banyak BMS lah, battery management system lah, riset kat Impidec.
Ya, battery management system. Itu pun baru kita start lah, tapi tak banyak. Untuk solar energy, dia punya teknologi already matured.
Okay.
Tak ada apa yang baru boleh diperbuat kan? So kita shift our this one to EV because we feel that EV is the next technology that everybody is talking.
Yesterday, Prof. Nasrin told us that he want to descend to hydrogen, alright? Hydrogen.
Hydrogen.
So hidrogen create sendiri atau macam mana? Atau membuat power untuk buat elektrolisis buat sendiri atau macam mana?
Dia more to the management system. Dia fuel cell kan? How you manage the fuel cell? Pak Chris, faham ke?
Okay, ya.
Dia more to the management of fuel cell. Tapi itu saya tak buat lah sebab it's not my area kan. Itu Dr. Syakil dia ada buat. Tapi itu more to the fuel cell, management of the fuel cell. Sama macam PV lah. Macam kita tak buat PV itu, kita hanya work on the system. So dia orang pun work on the system.
So power electronic improve kat sana di site yang mananya dia? Yang power electronic yang improve dalam fuel cell tu kat mana? How to produce atau setelah produce? Power
electronic akan datang bila dia orang dah produce DC kan?
Okay.
Fuel cell akan produce DC, so you want to DC kita tak boleh buat apa-apa. So DC you kena convert kepada AC.
I think you are concerned to generate hydrogen by power electronic, like design electrolysis circuit like that, no?
Itu the fuel cell punya proses lah, electrolysis process.
How to be convert water to be hydrogen?
Tapi itu tak banyak guna electronics. Itu material works on that on the system.
Okay, Dr. Jaras. Silakan ada lagi yang mau tanya, silakan. Ada lecturer atau kawan-kawan dari universiti lain. Di sini ada ramai tadi Dr. Jaras sampai hampir 100 tadi. Ada student, ada lecturer dari beberapa universiti kat Indonesia ini, ada yang dari Pekanbaru, Medan. Silakan yang dari Lancang Kuning, ada yang mau menanyakan Universiti Lancang Kuning. Yang dari Medan, silakan, dari Palembang. Pak David dari Pekanbaru, silakan kalau mau ada yang tanyakan. Ini dah masuk office Dr. Jaras.
Sudah masuk office Dr.
Bila Malaysia buka?
Malaysia buka. Border.
Ya, border.
Tak tahu lagi, Pak.
Jadi ke
Mungkin,
apa? Jadi ke Padang nih.
Jadi ke Padang. Tak tahu lagi lah, Pak. Macam mana? Kalau buka nanti saya datang ke Padang.
Oke, kalau kita dah siapkan arrange nih to visit some hydro power ya.
Boleh. Nanti
nak tengok geothermal power plant.
nanti saya bawa student saya pergi ke Padang.
Oke, silakan Bapak Ibu kalau masih ada yang mau bertanya. Pak Nov, silakan Pak Nov. Pak Fatlin, Bu Citra, Ibu Benriwati, Ibu Arleni.
Ada lagi?
Halo Pak Kris, bagaimana Pak Kris? Ini kayaknya sudah nggak ada yang bertanya lagi. Oke, kalau gitu tadi kita sudah mulai, sekarang kita serahkan kepada Pak Kris, mungkin ada yang mau disampaikan. Silakan Pak.
Oke, terima kasih Pak Snil. Sekali lagi, thank you Dr. Jaras to support our activity and sharing experiment, sharing knowledge to our center, our department ya. Banyak hal-hal yang bermanfaat ya, banyak ide, banyak pengetahuan, the new information we get from you ya. Kami sekali lagi mengucapkan terima kasih karena mau berbagi dengan kami semua ini, sehingga terbuka cakrawala kami tentang bagaimana perkembangan elektronika daya ya, yang dimanfaatkan dalam energi terbarukan, dan membuka wawasan daripada mahasiswa-mahasiswa. Oh di sini ya, oh di gini ya penerapan dari elektronika daya. Jadi elektronika daya yang sebagian mahasiswa mungkin menganggap itu menakutkan atau tidak punya harapan. Jadi setelah mendengar apa yang Dr. Jera sampaikan tadi, mereka terbuka wawasan mereka. Oh di sini ya pemanfaatan elektronika daya. Ternyata elektronika daya ini menjadi ilmu yang tren, yang masa depan yang dibutuhkan orang ini. Ya. Jadi terbuka motivasi mereka sehingga mereka lebih giat lagi belajar. Nah, sekali lagi terima kasih ya Dr. Jera setelah sharing informasi kepada kita. Jangan bosan-bosan ya. Kalau perlu kita buatlah, kalau Dr. Jera bersedia tak? Kalau mungkin dalam satu semester ada 2 atau 4 kali sharing tentang power elektronik, boleh Dr. Jaras? Boleh
Pak Kris, boleh.
Ya.
Saya juga mengucapkan terima kasih kepada Unitas Negeri Padang dan dengan juga Pak Kris,
ya.
Kawan baik saya, rakan
perjuangan. Kawan sekamar kita nih. Sangat 8 tahun kita berkawan.
Rakan seperjuangan.
Ya, the best friend nih.
So ya boleh, tak ada masalah Pak. Saya bila-bila you nak bagi saya lecture boleh. Nanti kalau lain kali boleh bagi topik lain pula.
Kalau sudah okey, Dr. Jaras, boleh tak kita visit atau apa? Kan kita kan ada grant collaboration di Sabtu. Macam mana kalau boleh kami duduk 1 bulan atau ada student internship kat UPDEC, boleh tak?
Boleh, tak ada masalah Pak Kris. Kita memang mengalu-alukan international student. Sekarang pun kita ada banyak, ada satu student daripada Jawa yang buat Master of Renewable Energy, dia scholarship. So bila border nanti, bila sempadan buka, nanti saya rasa Pak Kris pun boleh datang. Nanti kalau saya ada masa, saya pun boleh datang ke Padang.
Ya. Saya pun Dr. Jaras datang dan kita
saya pun nak bawa saya punya student Master of Renewable Energy melawat Universiti Padang dan juga geothermal kan Pak Kris beritahu hari itu?
Ada. Kita sudah coba cari info how to buat equipment dengan geothermal power plant.
Okay. So kita tunggu saja bila sempadan buka. Harap-harap Januari tahun depan.
Ya, harap-harap.
Ya.
Sekali lagi, thank you very much, Dr. Jaras.
Oke, Pak Kris, terima kasih. Terima kasih, Pak Kris.
Ya, Nandri ya.
Okay, thank you for attending. Yeah. Thank you everyone for attending. Ya Pak Aznil, terima kasih.
Oke, sama-sama Prof. Terima kasih Pak Kris. Oh ya, Prof. Jaras, mungkin bisa di-share yang presentasinya tadi, Prof.
Oke, saya akan hantarkan ke Pak Kris. Saya akan hantarkan ke WhatsApp.
Oke,
Oke,
boleh,
thank
Prof.
you.
Pak Kris boleh ya?
Thank you, Dr.
Kris?
Jaras. Ya, sukses selalu ya. Sehat
Alright,
dan
oke.
sukses selalu. Tetap semangat untuk
Oke,
riset.
terima kasih, terima kasih. Oke,
Oke,
terima kasih.
Terima
Sampai
kasih.
jumpa nanti di Kuala Lumpur.
Oke, terima kasih. Terima kasih. Jumpa lagi.
Terima kasih Prof. Jaras. Di lain kesempatan mohon tidak bosan nanti kalau seandainya kita mengundang lagi. Juga terima kasih banyak sudah sharing knowledge, sharing experience ke kita. Mudah-mudahan itu sangat bermanfaat sekali bagi kita semua untuk pengembangan kita ke depannya. Terima kasih sekali lagi Prof. Jaras, juga kepada Bapak Ibu semua dan rekan-rekan mahasiswa. Terima kasih sudah bisa hadir dan bergabung di pagi ini. Saya sudahi dengan Assalamualaikum warahmatullahi wabarakatuh. Terima kasih Prof.
Oke, terima kasih. Terima kasih. Terima kasih.
Pak, kita live Pak.
Iya Pak. Ya, hasil nanti bisa lihat di YouTube ya. Bagi yang sempat yang terputus-putus tadi sudah bisa menyaksikan di YouTube. Sekali lagi terima kasih Pak Asnil telah menjadi moderator co-host ya dan memandu acara ini. Kalau tanpa Pak Asnil ini belum tentu acara kita ini lancar ini. Ya, sekali lagi terima kasih. Banyak informasi, banyak yang dihandle oleh Pak Asnil selama saya pergi tadi. Sekali lagi terima kasih ya Pak Asnil. Juga semua partisipasi yang telah ikut. Mudah-mudahan ilmu yang kita dapat ini memberikan pencerahan terhadap kita dan kita semangat untuk terus meneliti dan berkarya dalam bidang kita masing-masing. Ya Pak Asnil, silakan Pak Asnil ditutup.
Terima kasih Bapak Ibu semua, terima kasih pada semua mahasiswa. Kita live lagi ya. Tutup lagi ya, kita tutup kedainya. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Assalamualaikum warahmatullahi wabarakatuh.
Malam ini nih, kami tampil ke, jangan dari Prodi dulu. Dari Prodi nanti ke